In previous video, we have clearly seen what chart should be chosen based on the scenario. So in this video, we are going to see how to create those charts with hands-on coding using Python. Let's get started. So what generally is the purpose of visualization? You are creating a virtual representation of your data that could be easy for clients to understand, and you can easily take information from them. If you have a table data, it is messy. You can't understand anything, right? You can't take any information out of it. When I convert that into a chart or when I convert that into a graph, I can easily understand what is going on. So that is the purpose of visualization. Now we are going to see using Python when we have big data, how we need to convert that into a chart to understand what is going on inside the data. So the first thing what you have to do is you need to import the necessary libraries. Matplotlib and Seaborn both are the libraries which is used for creating charts. It might be line chart, bar chart, histogram. So whatever charts we have seen in the previous video, we are going to create them using these libraries. Then pandas and numpy for data handling. The first chart that we are going to see is a line chart. Using this chart, what we'll be doing? We will see how continuous data differs over time, how it changes over time. So how to create? First, I'm creating a dummy data set with two different columns. One column is month and another column is usage. So month wise, it might be a current or an electricity or some charges that they pay off. Okay. So followed by that, I am going to use the syntax for creating charts. The first thing that I'm going to do is I'm going to give plot plt.plot, inside which I'll be giving months comma usage. These are the column names. Inside months I have month, inside usage I do have numerical values. Then I'll give comma marker which is equal to O. It is a small O, it is not 0. Then X label, plt.x label and plt.y label. In X label, we need to give month and in Y label, we need to give usage. Followed by that, you should give plot.show. So in X label, we do have month, right? See here. In Y label, we do have usage. When we give plt.show, the chart that it got created will be showed here. So this is how the line chart works. This is how you need to easily create a line chart. Next is bar chart. What exactly is bar chart? When we need that? Whenever I do have categories specifically, and I need to see the differences between those categories. Maybe the product sales, different types of product sales month-wise. Likewise, if we need to compare the categories, then I need to use bar chart. So here, how to create a bar chart? If you could create a line chart, you need to make very few differences in the syntax. First, I'm creating the data. Here, what I'm doing is, I'm comparing the number of projects department wise. If a company is frequently getting AI projects based on the domain, how many projects do we got? If we need to check that, the go-to chart is obviously a bar chart. See here, in departments, I'm giving the department names. HR department, finance, R&D, and marketing. In the projects, I'm giving 4, 6, 12, and 5. So it specifically tells us about the number of projects. When I give plt.bar, I am going to call the names of the columns. So first column is going to be plotted on x-axis. The second column will be plotted on y-axis. When I give plt.title, I am going to specify the name of this chart, bar chart. So AI projects by department. That is what I am giving as a name of the chart. Followed by that, I need to go plt.show. What is the use of that? It is going to create the chart as per whatever I have specified here. See, with the title AI projects by department, I got a bar chart. Based on the values I have specified here, I got this chart. So by seeing this chart, you can easily understand based on department, how many projects, how it differs. Then the histogram. This looks as similar to bar chart, but there is a big difference. See, The biggest difference is it is used for understanding the data distribution. Bar chart is for understanding the data, how it got distributed category wise. But when I have a particular numerical column, for example, if I have group of people, in that I want to figure it out which age of people are of more. I want to see that. I want to figure it out. So for that, what chart should I use? I need to use histogram because this is specifically used for understanding the data distribution, how age is being distributed. So when I create data like this, see how I'm creating data here using NumPy. We have already seen, right? When learning NumPy, we have seen how to create values, how to create data using NumPy. So using NumPy, I'm giving np.random.random and I'm giving the range 20 to 50, then I'm giving 50. Followed by that, I'm giving plt.hist. Why? Because I'm going to create a histogram and this is the syntax. And ages is something that I'm going to plot. Then I'm giving the bin value. What is the bin value? Exactly, this is the number of bars. See, 1 bar, 2 bar, totally the 6 bars are there. So that is the actual bin value that I'm giving here. Then I'm giving the title. plt.title is age distribution. How the age value is being distributed. So that would be given inside the plot.title. Followed by that, I'll be giving plot.show. So the chart will be created. This is how beautifully you're going to create the histogram. So this is specifically used for what? For understanding the data distribution. So that is the purpose of creating histogram. So the next chart that we are going to see is box plot. We have seen this two times. Where? While understanding outliers. And yesterday in the previous video, we have seen what is the purpose of box plot and how it looks like. What is the purpose of box plot? Tell me now. What is the purpose of creating box plot? It is used for finding outliers. So when I plot a box plot like this, it will be helpful in understanding how my particular data, if I have any data that is deviated from my average minimum or average maximum. When I have set of all values, there will be a set of range inside which all my values should come. If my particular value is deviated, if it is less than that or if it is greater than that, that is actually an outlier. To figure out if my data has any outlier, I'll be using this box plot. So for understanding that, I'm creating data with an outlier. See, in salaries, this is the data that I'm creating in salaries variable. I'm giving 6 different numbers, 35, 30, 35 likewise. But one number is completely exceeding the range, that is 100. So it says that it is an outlier. So when I plot a box plot, see the syntax. So here I'm using Seaborn library. So for calling that library, I'm using sns.boxplot and I'm giving y equal to salaries. So these values represent salaries from 30 to 100. Then I'm giving plot.title as salary distribution. This value is used for, this chart is used for understanding the salary distribution. When I give plot.show, it will be showing my particular salary that is deviated from my average set of salary. See, and 100 we have a dot, right? That represents an outlier. When you create a box plot for a big data, this is how all my outliers will look like. Here we just have one value, right? When my messy data, when I work with my messy data, I could see so many outliers like this. Then the scatter plot. This is such an amazing chart when you need to understand the relationship between two numerical columns. Specifically, here we have a case study. If I want to understand the relationship between study hours and score, if I want to understand the relationship between age and weight, I want to understand the relationship between height and weight when checking BMI values or something. So if I want to understand the difference, the relationship between two numerical columns, then a go-to chart is obviously a scatter plot. So see here, I'm creating data with two different columns, hours and scores. So how a student score is having relationship with a hours, the study hours. So that is what I'm going to study here. I'm going to understand the relationship between two numerical columns. So here I'm giving random 5 values for hours and 5 values for scores. Then I'm creating a scatter plot. For that, the syntax is plot.scatter. Then I'm going to call the column names. Hours on x-axis and scores on y-axis. The first value I'm giving inside this plot.scatter will be taken for x-axis and another value is for y-axis. So to confirm that, next to that, this is something that you specify it. Followed by that, if I want to see and understand my chart, I need the labels here, right, on x-axis and y-axis. So for adding that label, I'm giving plt.x label and y label, and I'm specifying the name of the columns. For house studies, what is the score? Like this, I'll be plotting my scatter plot. Then the title. The title is obviously customizable. So based on my need, I'm giving marks difference based to study hours. Then when I give plot.show, the chart will be created like this. So see, you can easily study the relationship between hours studied and score just by looking into this chart. So whenever a student study for more hours, I can see that student scores more. If a student study for just 1 hour, they are scoring 40. If they study for 5 hours, they are scoring 80 plus. It's 90 or 90 plus. So it has a relationship. To study this relationship, you are using scatter plot. Finally, we have one chart called heat map. This is a commonly used chart in most of the table data set. So whenever I have a machine learning model that needs to predict a particular target column, before applying a machine learning model, this is actually a sample of machine learning model. This is a demo piece of a machine learning model because it is specifically used for understanding the relationship between features and target. What is exactly a feature and what is target? In my table, I have a separate column that I need to predict. That is a target. And the columns that I'm going to use for predict are called as features. So here, when we have a heat map, when I create a heat map like this, this is used for understanding the relationship between that target column and that remaining features. So what is the target column here? So score is the actual target column. So based on number of, based on the hours students studied, based on the assignments they did, we can easily judge how much they could score. So for that, we are creating a chart here. Now look into the syntax. Here we are creating a data frame. For that, I'm using pandas. So we need a data frame inside which I'm creating 3 different columns: hours, score, and assignments with random values that I could specify here. Then I'm giving sns.heatmap, df.correlation, and I'm giving and or true. So this is the syntax. So using Seaborn, I'm going to create a chart. Then I give plot.show. The chart will be created like this. So this is how you need to create a heat map, and this is definitely something you should create in every data science or ML or AI project to understand the relationship between features and target variable. Yes, we have seen so many things today. Then finally, a memory trick. So we have seen 6 charts, right? When to use these charts. A short trick that you could understand. Line chart. When should I use it? When my data differs based on timeline, continuously changes based on timeline, then I should use line chart to understand it. Maybe you have seen in stock market analysis and all, the month wise you have seen a line chart, right? So that is how line chart works based on this time wise columns. Then when I need to compare the categories, the go-to chart is obviously a bar chart. Monthly sales value, likewise I need to compare. If I need to compare, then I need to use bar chart. Then histogram. Histogram is specifically used when I need to understand how my particular numerical column is being spread, how my data is being spread. To understand how it is being spread, I need to use histogram. Then outliers. Whenever I have a particular data that is deviated from my range of data, then the go-to chart is obviously a box plot. Then we do have scatter plot. What is it? Scatter plot specifically used for understanding the relationship between two numerical values, two numerical columns. When should I use this scatter plot? Understand the relationship between two numerical columns. And finally, when I need to understand the relationship between Target value and features. What should I use? It is a sample of machine learning models. What is it? It is heat map. So I believe you clearly understood how to create these charts and you have clarity on when to use these charts if you remember this memory tech. If you have any doubts, without hesitation, drop them in comments. Bye for now. We'll meet you in next amazing video.